So in this video, we're going to try to figure out what 0 raised to the 0th power is equal to. And to do this, we're going to start by looking at a few simple concepts. First, what does a to the n mean, right? A to the n, well, we could look at what a squared is, and that would be equal to a times a, right? And if we looked at a cubed, that would be equal to a times a times a. And if we look at these few examples, we can deduce that all a to the n means is we take a and multiply it by itself n number of times. So we take a and multiply it by itself twice. We take a here and multiply by itself 3 different times. Simple, right? Well, now let's get into some index laws. What about a to the n times a to the x? Well, all we could do here is we could say a to the n plus x. Since we're multiplying, we just add the powers, and that would be sufficient to answer this problem. Similarly, we could do a to the n divided by a to the x, and that would be equal to a to the n minus x, right? So what would happen if n and x were the same number? Say n was 1 and x was 1. That would be equal to a to the 0th power, right? But if we look at, say we said a was 3 and n and x were 1, that would be 3 to the first divided by 3 to the first, which would be, if we rewrote it as 3 to the first divided by 3 to the first, this would be equal to 1, right? So according to this logic, a to the 0 is equal to 1. But if we went to another set of rules and we said 0 to any power is equal to 0. So if we said 0 to the first power, that would be equal to 0. 0 to the 50th power is equal to 0. According to these two separate rules, it seems to contradict each other. This one rule is saying when we a to the any number raised to the 0th power is equal to 1, according to this. But down here, we found that 0 raised to any power is equal to 1. So if you approach the problem from the perspective of any number raised to the 0th power is equal to 1, you get 1. Conversely, if you approach this problem from the perspective of 0 raised to any power is equal to 0, you'll get 0. And a way we can approach this to figure out which one of these laws would work is we can look at it from a perspective of limits. What we're about to do is figure this out with something called limits, and we're going to do it with a chart. So we are going to, over here, we are going to write this column as value, and over here we're going to write all the different values. And excuse my egregious attempt of drawing a line. You're just gonna have to bear with it. Okay, there we go. There's my line. Here's my chart. So what we're going to do is we're going to start with 1 to the power of 1. And what we're going to try to do is we're going to try to get closer and closer to 0. So 0.9 to the 0.9th power. And 0.8 to the 0.8th power. And we're going to continue to do this and see what happens as we get closer and closer to 0. And try to figure out what 0 to the 0th power actually is. So if we did 0.7 to the 0.7th power, 0.6 to the 0.6th power. And you can type this into your calculator to verify these answers, but I'm just going to write them down. So 1 to the first power is 1. 0.9 to the 0.9th power is 0.909. 0.8 to the 0.8th power is 0.836. 0.7 to the 0.7th power is 0.779. And if you stop here and you try to figure out what pattern is actually occurring, you'd guess that it was going to 0, right? As we get closer and closer to 0, so far, it's going down. It went from 1 to 0.909, from 0.909 to 0.836, and it's continuously going down. But let's continue and see what happens. So from 0.6 to the 0.6 power, we're going to get 0.736. And it's still going down, but it doesn't seem to be going down quite as rapidly. So 0.5 to the 0.5th power would be 0.707. 0.4 to the 0.4th power would be 0.693, 0.693, 0.3 to the 0.3 power, 0.3 to the 0.3 power would equal to 0.696. And this is where things take a change. As you can see from here down to here, everything has been going down closer and closer to 0. But as we get to 0.3 to the 0.3 power, it seemingly is actually starting to increase in value and get closer to 1. But what we need to do is continue down with this pattern and see if that actually gets to 1. So 0.2 to the 0.2nd power is equal to 0.724, 0.724. 0.1 to the 0.1 power is equal to 0.793, 0.793. And it's still going on that pattern. So let's go even further. Let's do 0.02 to the 0.02nd power. That would be equal to 0.924. And let's do 0.01 to the 0.01 power, and that would equal 0.954. It seems to go to 1, but let's speed up this process a little bit. Let's do 0.12340 1 to the 0.12340 and that would actually equal 0.99988. And as you can see, this is continuously getting closer and closer to 0. You can check with your calculator. The closer you get to 0 to the 0th power, the closer you will get to 1 on your calculator. And you can try that at home yourself. And what we actually have been doing here is taking a limit. And you'll be introduced to limits in calculus, but what it's essentially saying is we're approaching a certain number, and in this case we're approaching 1, and we can get closer and closer to that number, but we'll never get there. And the notation for this actual limit that we're talking about is this: the limit as x approaches 0 of x to the x is equal to 1. This is actually what we've been doing with this chart. And it's saying is as x approaches 0, what happens to x to the power of x? Well, it gets closer to 1, as we have proven here with the calculator. And you can continue with this pattern. You can go to 0.000001 to the power of the same x, and as you'll see, you'll get closer and closer to 1, but you'll never actually reach it unless you type in 0 to the 0th power. So I hope this video has shown you that through limits, that if that 0 to the 0th power is actually indeed equal to 1, even though that over here this law states that 0 to any power n is equal to 0. Like, comment, and subscribe, and I will see you guys in future videos.